Now we discuss how to calculate the pressure inside a pipeline or a container using a manometer consisted of different columns of fluids. We will directly use the integration formula of fluid pressure in this example. A more straightforward example will be discussed in another video. Now we want to detect the pressure inside a water pipeline marked by the yellow color. One method of this detection is connecting the pipeline fluid to a manometer of multiple different columns of fluids. In this case, there are mercury, alcohol, and oil filled in the manometer. The geometry of each section of different fluids are given by the values of H1, H2, H3, and H4. In order to solve this problem, let's mark each key point with a number. Point 1 is the interface between the atmosphere and the oil section. Point 2 is the interface between the oil section and the alcohol section. Point 3 is the interface between the alcohol section and the mercury section. Point 4 is the interface between the mercury section and the water section. Point 5 is just the place where we want to obtain the value of pressure. Due to the formula of fluid pressure, the pressure difference between point 1 and point 5 can be generally written out as the integration of ρ as a function of depth z, multiplied with the gravitational acceleration g, multiplied with the derivative of depth dz, from point 1 to point 5. It can be then decomposed into 4 sectional integrations, from point 1 to point 2, from point 2 to point 3, from point 3 to point 4, and then from point 4 to point 5. Within each section, the density of fluid is a constant. From point 1 to point 2, the density can be written as ρ oil. From point 2 to point 3, the density can be written as ρ alcohol. From point 3 to point 4, the density can be written as ρ mercury. From point 4 to point 5, the density can be written as ρ water. Now what's left inside the integration is just the depth z. Our knowledge of calculus tells us that the definite integral can be written as difference of z between 2 and 1, between 3 and 2, between 4 and 3, and between 5 and 5, respectively for these 4 sections. Please pay attention. Here z is the depth, not the height, so the lower one point is, the larger value of depth it has. Therefore, the depth difference between point 2 and point 1 is positive, the depth difference between point 3 and point 2 is positive h3, and the depth difference between point 4 and point 3 is positive h2. However, because point 5 is higher than point 4 in altitude, depth 5 minus depth 4 will be negative. So it is negative h1. Rearrange the Hu equation, we obtain a full expression for P5, where P1 is nothing but the atmosphere pressure. Now we plug in the numbers of these variables. The density of water is 1.010 to the third kilogram per cubic meter. The density of mercury is 13.610 to the third kilogram per cubic meter. The density of alcohol is 0.7510 to the third kilogram per cubic meter. And the density of oil is 0.8510 to the third kilogram per cubic meter. The gravitational acceleration is 9.81 Newton per kilogram. The atmosphere pressure is 101 kilopascal. The length of pressure causing fluid columns are H1 equals to 0.7 meter, H2 equals to 0.2 meter, H3 equals to 0.3 meter, and H4 equals to 0.4 meter. Putting these together, we shall have P5 equals to 126.4 kilopascal, which is just the absolute pressure inside the water pipeline. For another easier to understand method, please turn to the next video. Thank you for learning. Feel free to subscribe and like if needed.